Today, we're going to be learning about complex fractions. We're going to be simplifying them. And a complex fraction is a fraction in which the numerator is a fraction, so maybe x plus 4, and the denominator is a fraction. Those are complex fractions. So what we're going to do is we're going to create a single fraction in both the numerator and the denominator, and we're going to set it up as a division problem. Remember, for division problems, you keep, change, and flip. So how we would solve this is we'll keep this one the same. We'll change it to multiplication, and then we'll flip this second fraction so that it'll be 3x over x plus 2. And then you would solve as usual. Okay, so let's do an example. So first, we're going to keep this fraction, change it to multiplication, and we're going to flip this bottom fraction. So this will be 4 over a squared. And then we're going to simplify this. So a times 4 is 4a, and the denominator becomes 2a squared. When I simplify this, what would it become?
2a.
Perfect. 4 divided by 2 is 2. You have an a canceling out, so you're left with an a in the denominator. We're going to use the same concept here. We're going to keep this fraction the same, and we're going to flip the second fraction so that it looks like this. Now I can multiply across. 6 times 8 is 48. I have 3, a single x, and I have y squared. So we're going to simplify this. 48 divided by 3, 16. I have an x canceling out with just one of the ones in the numerator, so that will be an x squared, and I'm left with y squared. All right, let's look at a different example. Let's look at number 8. We're going to use the same strategy. We're going to keep the numerator, the first fraction, the same. Change it to multiplication. And then I'm going to flip the second fraction. So this will become 9m squared plus 36m over m cubed minus 5m squared. All right, so we're going to simplify this. We're going to factor. So let's do the numerator. So what can all of these be divided by? 2. So 2 will be on the outside. This will be m squared minus m minus 20. So I can now do an eye chart. I'll need 2 numbers that multiply to negative 20, add to negative 1.
Negative 4.
And 4. Perfect. So I can write the numerator as 2 times m minus 5, m plus 4. That's the numerator of the first fraction. The denominator, what can both of these be divided by? 3. So we're going to pull out a 3, and we'll be left with m plus 4. So that's our first rational. Let's do the second one. This numerator, what can we take from both of them? 9, that's it? And there we go. Tell me what we're left with.
M plus n.
M plus 4. All right, what can we divide this denominator by? M squared. Tell me what's left. Perfect. Okay, now we can just cancel things out. M minus 5 cancels with the m minus 5 in the numerator. These 2 cancel out. Okay, I'm just going to write down what I have. Right now, I have 2 times 9m, that is 18m, with an m plus 4. My denominator is 3 times m squared. Okay, let's simplify this a little further. What's 18 divided by 3? 6, so I'll have 6. This m cancels out with one of those m's. So I'm left with 1m in the denominator. and I have n plus 4. That's my answer. All right, guys, look and see how this example is a little bit different. Find this example. Notice, guys, that I do not have a single fraction. I have one item here and another item here. I need to combine those into one fraction, okay? So, guys, just for now, I'm gonna ignore the numerator. Just ignore it for now. Let's just focus on the denominator. I'm gonna write it nice and big over here. All right, so in order to combine these fractions, the denominators need to be the same. So what do I need to put down here? Exactly. We'll put it in the numerator as well. Okay, so let's go ahead and combine the fractions. Now that the denominators are the same, you just copy it down. W plus 2 times 1 is still just W plus 2. So I'll have W plus 2 minus W. So what's my answer? Exactly. W minus W cancel. I'm left with 2 over W plus 2. Now I can rewrite my original problem. We did not do anything to the numerator, that just stays the same. But we rewrote the denominator as 2 over W plus 2. So first I had to turn this into a single fraction. Now I can keep change flip. So we can keep change flip. We'll keep this first fraction, change it to multiplication. Now we're going to flip this denominator. So the 2 will be in the denominator. W plus 2 is in the numerator. That cancels, that cancels. Your answer is just W over 2. Okay, so guys, again, we do not have a single fraction here. We need to condense it into one fraction. Here, we do not have a single fraction, so we have to condense it. So guys, let's work on the numerator first. I have 1 over A squared minus 1 over B squared. What do I do to make them the same? I can put a B squared here. And what do I put on this one? An A squared. Now they match, right? Now the denominators are the same, so just copy down the denominator. And now we'll add the numerators. This is just B squared minus A squared. Great, I have a single fraction. Now, let's worry about the denominator. I have 1 over B plus 1 over A. Let's turn this into a single fraction. What do I need on this first one? An A. What do I need on this one? A B. Whatever you do to the numerator, you also do to the denominator. You have to do the same thing to the top and bottom. So now my denominators are the same. So this is just AB in the denominator. And the numerator is just A plus B. Okay, so I rewrote these into a single fraction. Let me just go ahead and put my division symbol. This is our new problem. Okay, keep change flip. So guys, I'll do that over here. We're going to keep the same numerator. So B squared minus A squared over A squared B squared times, we're going to flip this second one. So AB is now in the numerator. A plus B is in the denominator. Sorry. Okay, guys, let's go ahead and factor. Do you guys see this over here can be written as B minus A times B plus A? B times B will give you the B squared. BA minus an AB, they cancel out. And then A times A will give you that minus A squared. So you can rewrite that as this. Yes. All right, so we can rewrite this as B minus A over B plus A squared B squared times AB over A plus B. What cancels is those two. I'm left with AB times B minus A over A squared B squared. A cancels with one of those A's, B cancels with one of those B's. So my final answer is B minus A over AB.